Hello, this video is going to cover some of our bases for working with percents in our current unit. So in order to be able to do that, we have to have an idea of how to solve percent problems. So I'm going to be covering percent proportion and percent equation in this lesson. Two different methods for solving percent problems. We've worked with proportions in our prior unit, and percent equations are used for a lot of different situations. For example, calculating prices after sales tax, or calculating prices after a discount, or working with interest rates like simple interest, which we'll cover this year. So both of these are ones to be familiar with, although you'll be able to choose which method you prefer. We generally will stress one of them in each of our lessons. So our first method for solving percent problems is going to be the percent proportion. And I did put it in this box here for us. It is P over B equals R out of 100. What's really important for us is that R has to be the percent, which I know seems weird because we think it has to be P. But in this case, R is our percent. We use that because R is used for rates a lot of times, which is a percentage. We do not write it as a decimal since we are putting it over 100, and the percent will always go over 100. We do not need to write the percent as a decimal. Now, the reason why I stress that is for the percent equation, we will need to write the percent as a decimal. The P actually represents the part or the portion out of the total, whereas B is our base or total or whole number. There's lots of different words to use for that. If we're given the percent, that's really easy to identify. If we're given the base, that's the next easiest one to identify because that's our total. It doesn't have to be the largest number. It often is, but it's going to be our total. And then the part is the portion of that. And one of these is going to be unknown because we have this proportion with 4 different parts. We know that 100. We're going to be given part and base and find the percent, or part and percent, and we have to find the base. Because again, this is our proportion. We have 2 fractions set equal to each other, which is what we worked on a little bit in our last unit. Now you're gonna notice off to the right here, I have is over of equals R over 100. And that's because the percent R always goes over 100, but pretty frequently we are going to see our base near the word of, like out of some number, and our part is typically going to be nearest the word is in the problem. Again, this is not always the case, but we're often going to see that. And that's because if we say, for example, in number 2, 295 is, meaning it is part of some other number. So let's look at some examples. Now, there are a few that are done for us that I'll just kind of read through. The other ones that you need to copy down, please make sure you're pausing as needed to copy those down. All right, let's go ahead and start with number 1. Number 1 says, 48 is what percent of 52? Now we are not given the percent here at all, and you'll notice that I'll actually list PBR out and identify which one is my unknown with a question mark and identify the other 2 that are known to us. But in this case, our percent is our unknown, so you can see that I left the R as an R. If you prefer to change it to a variable like X, you are welcome to do that. Now, 48 is what percent of, meaning out of 52. 52 is our base, so I have my proportion. I'm just starting to fill those numbers in. 48, it's not the percent because it does not have a percent sign after it, so it has to be the part. So 48 out of 52 is R out of 100. We want to figure out what that is as a percent. Now, are there other ways to do this? Yeah, you could actually take 48 divided by 52 times 100. That would also get you the percent as well. Or take 48 divided by 52, get the decimal, and then convert that decimal to a percent, which is something you should be able to do. Like if you have a quiz and you received a 48 out of 52, you should be able to find that percentage. But a proportion also works. Now remember, we did a little mini lesson in our last unit on solving proportions. We're going to cross multiply. So 52 times R is this 52R. 48 times 100, I'm not writing out 48 times 100, I go right to 4,800. Now this is 52 times R, and the inverse of multiplication is division. So we'll divide both sides by 52 to get about 92.3. If I remember correctly, and of course I don't have my calculator handy right now, I'm actually in my son's bedroom recording this right now, but I believe it might be a repeating decimal. I did round it to the nearest tenth. If it is a repeating decimal, you can write the exact percentage. 0.1% is not going to be a significant difference if we're talking about small numbers, but if we can write exact answers, we certainly can do that. So we get about 92.3% for our percentage. And I did put a percent sign after it since we're trying to find R, the percentage. So number 2, now you are welcome to try number 2 on your own first and then unpause the video and check to see if you have the same solution. After looking at number 1, it's your choice. But for this one, what I am noticing, it's a similar setup to number 1. I do not know the percent, which is R. I do know the base or the total is 400. So 295 is what percent of, meaning out of 400. 295 is the part. So we've got P over B equals R over 100. Let's go ahead and plug those in. That will be 295 over 400 equals R out of 100. When we cross multiply, we're going to get 400R equals 29,500. That is from 295 times 100. Again, pause the video as needed if you need to copy something down. The inverse of multiplying by 400 is to divide by 400. So we'll divide both sides by 400, and 29,500 divided by 400 will get us our percent, and that will be 73.75%, which I actually originally forgot to type my percent sign in there, so I added that in last minute, but about 74%. Now, at the bottom of your page, it does recommend you stop and think, does my answer make sense? Like 295 out of 400 is pretty close to 300 out of 400, which is the same as 3/4. 3/4 is 75%. This is pretty close to 75% for us. All right, let's take a look at our next example. This one's a little tricky because our base is actually smaller than our part. So when we say what percent of 22, meaning out of 22, is 56. Once again, the percent R is my unknown, but the base is actually 22. So you can see I plugged it in down here. Whoops, sorry, I'm clicking around too much. Down here on the bottom of our fraction, and then the part is going to be up here. So 56 over 22 equals R out of 100. 22 times R is 22R, and 56 times 100 is 5600. We'll divide both sides by 22, and we get 255.5%. That squiggly equal sign, by the way, just means that I rounded that answer. If it's a repeating decimal, we could write the exact answer. Again, I didn't grab my calculator before I came up here to record this video, but if it is a repeating decimal, you're welcome to write exact answers as well, or a terminating decimal, which is one that ends at some point. We'll talk about that in a later unit. All right. So next question, what percent of 4 is 15? Again, you're welcome to try this one on your own. Our percent, again, is our unknown. Our base is 4 because it's what percent of 4 is 15. So when I identify these things, and I like to write this off to the side. So the part is 15, base is 4, R is my unknown. When I plug those in, percent proportion is P over B equals R out of 100. So that will be 15 over 4 equals R out of 100. We'll cross multiply. 4 times R is 4R. 15 times 100 is 1500. Divide both sides by 4. 1500 divided by 4 gets us 375%. So we actually notice in these two problems, when our part is bigger than our base, we get a percent above 100%, which we might be thinking, is it possible to have percents above 100%? Sure. If we're talking about inflation, that's an example where we might see percents over 100, or the rates that are charged by a business, for example. Often a business might buy a product, or it may only cost the company, let's say, $10 to make a product, and they're going to sell it for much more than that to earn a profit. So we can use percentages above 100% to represent those. So we will see some percents above 100. All right, continuing along. Now we've seen where our percent is unknown. Let's talk about an example where our part is unknown. So number 5, what is 99% of 840? 99 is my percent, 840 is my base, because it's what is 99%? What is part of that total of 840? So we have P over 840 equals 99 over 100. Keep in mind that percent always has to go over 100. When we cross multiply, we've got 100 times P is 100P. 840 times 99 is 83,160. Divide both sides by 100, and we get that our part is 831.6. This makes sense because 99% is almost 100% of 840, so our answer should be pretty darn close to 840, and it is. All right, let's take a look at number 6. Again, I want to remind you, you're welcome to try this one on your own, pause it, and then check to see that you're correct. It's up to you. So this one, 4.5% is our percent R, and we're saying what is 4.5% of 38, which means out of 38. So 38 is our base, R is 4.5, and our part is our unknown. So we have P over B equals R over 100. That will be P out of 38 equals 4.5 out of 100. When we cross multiply, we've got 100 times P equals 38 times 4.5, and 38 times 4.5 is 171. Divide both sides by 100. Remember, the inverse of multiplication is division, 100 times P, so we divide by 100. That's going to get us that our part is 1.71. I did not round this one to the nearest tenth. It was a short terminating decimal, meaning it ends at some point. There's no need to round it to 1.7. All right, let's take a look at another one. Now, this one could be written as what is 16% of 36.2, but instead of saying that, we said find 16% of 36.2. We're given the percent as 16 and the base is 36.2. Our unknown here is the part. So we have P over B equals R out of 100. It will be P over 36.2 equals 16 out of 100. We'll go ahead and cross multiply. 100 times P is 100P. 16 times 36.2 is 579.2. We'll divide both sides by 100, and this will get us a fairly short terminating decimal, 5.792. Again, it's short enough that I think it's okay to write it. Sometimes it's beneficial to round it. Obviously, depending on the circumstances, determines whether we want to round it or not. All right, so we have had our part as our unknown. We've had our percent as our unknown. Let's talk about our base being our unknown. So number 8, it says 85 is 80% of what number? So 85 is some part of some other number that we don't know. 80 is clearly the percent here. It's got a percent sign after it. So when we fill in our percent proportion, it's going to be P over B, or 85 over B, equals 80 out of 100. Again, that percent always goes over 100. And I know my part, I did underline the word is, because often the part is going to be closest to the word is in the problem. Again, that's not always the case. You want to think about it as well. Sometimes we rely on these hints and strategies and shortcuts. We want to also think, does this make sense that it's the part? It does. So 85 is that portion, that 80% or 4/5 of something else. When we cross multiply here, 85 times 100 is 8,500. 80 times B is 80B. Divide both sides by 80, and we get that our base is 106.25, and that makes sense. So we can say 85 is 80% of 106.25, and that statement makes sense. If we get something that isn't reasonable, that final statement will not be reasonable and will not make sense. All right, let's take a look at number 9. So 4.5 is 90% of what number? 90% is our percent. 4.5 is our part. We've got to find our base. Ooh, I am missing some letters there. So we will type those in really quickly. That's P, B, and R. It must not have copied over. I've recorded this video before, but I was re-recording it with some edits that I made. So not everything copied over. All right, so we have P over B equals R over 100. That will be 4.5 over B equals 90 out of 100. Cross multiply, 90 times B is 90B. 4.5 times 100 is 450. Divide both sides by 90, and we will get that our base is 5. Ignore that random line afterwards. My cursor must have been there when I copied it over, and I was not going to retype it. So we'll just know that our solution is B equals 5. That is not a 51, just to point that out. All right, and that makes sense, by the way. 4.5 is 90% of 5 because 4.5 and 5 are pretty close to each other. That's one strategy. The second strategy is going to be our percent equation. And honestly, the percent equation is probably used more frequently in real life, which is why we talk about it here. Sometimes students find the percent proportion to be simpler because they're more familiar with proportions. But the percent equation, quite honestly, is used for a lot of real life situations. For example, finding a final price after 6% sales tax, finding the price after a 25% discount. We often are using a percent equation for that. And this is P equals R times B. So we're still using P and B for the part and the base. R is still used for the percent, but you're going to notice here that it says we want the percent to be written as a decimal. So I'm going to highlight that even though it is bolded and underlined. We want to write the percent as a decimal. And you can see that I stated it's used in a lot of real life situations and formulas. That's why it's important for us. So number 10, when we see that it says find 75% of 25, we know that the base is 25, meaning out of 25, and the percent R is 75%. But you will notice, I actually should have kept my highlighter, that I wrote 75% as 0.75. We moved that decimal point to the left 2 places to change it from a percent to a decimal. So our part P is our unknown. So we have our percent equation, P equals R times B. That's going to be P equals 0.75 times 25. Now we do not need to use inverse operations here because it's multiplication between 0.75 and 25 and the variable is on the opposite side. We did a little mini lesson very early in the year where we determined whether to use inverse operations or not. We do not need to here because the thing that we are trying to find is already by itself. So we don't need to isolate it. So just take 0.75 times 25 and that is going to get us 18.75. Again, really important points is making sure the percent is written as a decimal. Definitely important for us. So let's try a couple of these. 11 and 12, certainly if you want to try them on your own, you're welcome to do that. Number 11, if you want to listen to that one and then try number 12 on your own, it's not really a bad strategy here. So number 11 says find 9% of 410. So 410 is our base. 9% is our percent R, but as a decimal, that will be 0.09. We move the decimal point at the end of 9 to the left 2 places, which involves adding a 0 after the decimal point. So we'll get 0.09. So if we have P equals R times B, we're going to have P equals 0.09, the percent R as a decimal, times the base, which is 410. 0.09 times 410 is 36.9. Now I want to stress that if you do this same problem using the percent proportion, just keeping 9 as 9 out of 100, you're going to get the same solution. So it's fine to do it either way. Pick which one you prefer. Pick which one you like a little bit better to use and use that strategy or use that method. I personally like the equation a bit better, but a lot of students prefer the proportion, and that's okay. All right, number 12, find 40% of 7. So 7 is our base, 40% is our percent R, but as a decimal, that will be 0.4 or 0.40. The part is our unknowns. And we have P equals R times B. That will be P equals 0.4, 40% as a decimal, times 7. This makes sense, by the way, because we're trying to find 40%, which is 0.4 of typically means multiplication, so times 7, and that's going to get us 2.8 for our solution. All right, moving ahead to number 13, 256 is what percent of 800? So this is actually a little bit harder than the last couple because our percent is our unknown, so we will need to use inverse operations. 800 is going to be our base, our percent, R is going to be our unknown, and 256 is that part. It's the same setup as it was for the percent proportion, identifying P, B, and R. So when we have P equals R times B, you'll see that right here. That'll be 256 equals R times 800. The inverse of multiplying by 800 is to divide by 800, and we get that R equals 0.32, but we do want to write that as a percent, and it's not 0.32%, it's 0.32, which is equivalent to 32%. So we'll have to move that decimal point to the right 2 places to convert our answer into a percent. And that makes sense. 256 is what percent of 800 is, like 300 out of 800. 300 out of 800 is going to be 37.5%. So this kind of makes sense to be around 32 or mid 30s percent wise. All right, so number 14, 2089.5 is what percent of 2100? So the part is 2089.5, the base is 2100, and R is the thing we do not know. So if we have P equals R times B, that is going to be 2089.5 equals R times 2100. Divide both sides by 2100 to get that R equals 0.995. Now, we do want to write that as a percent. So when we do that, move that decimal point to the right 2 places. You can see that down below. That will be 99.5%, which makes sense because 2089.5 and 2100 are really close together. All right, number 15. 15.4 is what percent of 55? Our base is 55, the part is 15.4, and R is our unknown. So we'll plug those in. Keep in mind, if you need to pause a video at any point to jot this down, please feel free to do that. So P equals R times B will be 15.4 equals R times 55. Divide both sides by 55. 15.4 divided by 55, make sure you're working top down when you divide. So top number divided by bottom number, it's a good reminder for us. 15.4 divided by 55 is going to get us 0.28, and move that decimal point to the right 2 places to get 28%. All right, final type of example with percent equations is where we're trying to find the base. So number 16, 36 is 9% of what number? 36 is our part. 9% is our percent R, and 9% as a decimal is 0.09. So when we have P equals R times B, that will be 36 equals 0.09 times B. The inverse of multiplying by 0.09 is to divide by 0.09, and 36 divided by 0.09 gets us 400. Remember that when we divide by a decimal less than 1, it actually makes the number bigger, in this case in a significant way. And this makes sense. Like 36 is 9% of what number? It's pretty close to 10% of some number. So if I were doing 10% of 400, that would be around 40. 36 is pretty close to that. It's a little bit below, which makes sense. All right, number 17 and 18, again, if you want to try these on your own, you are welcome to do that. Pause the video as needed and scroll ahead as needed as well, but make sure you get these. So 2,925 is 39% of what number? The part is 2,925. 39% is R, the percent. We will write it as a decimal though, and that will be 0.39. Our base is our unknown. So P equals R times B will be 2,925 equals 0.39 times B. The inverse multiplied by 0.39 is to divide by 0.39. 2,925 divided by 0.39 is going to give us 7,500 for our solution. Again, dividing by those small decimals will make our number significantly bigger, which should not be a surprise for us. All right, last one of these before we do a handful of word problems, of which we'll see many in this unit. 576 is 90% of what number? So 576 is our part. 90% is the percent R. We will write it as a decimal though, which will be 0.9, and our base is our unknown. So when we have P equals R times B, that will be 576 equals 0.9 times B. The inverse of multiplying by 0.9 is to divide by 0.9. 576 divided by 0.9 will get us 640 for our solution. So 576 is 90% of 640. All right, now our remaining questions are going to be word problems. I do want to make an important note though first. When using a percent proportion, remember that you do not write the percent as a decimal because you are already putting your percent over 100. But when you are using the percent equation, you will always write the percent as a decimal. Sometimes I have kids who don't do it and then they have to move the decimal point at the end. And let's be honest, it's easy to forget that step at the very end of a problem. All right, so for our word problems, you may use whichever method you choose to do these. I will show both methods, and I'll go through them pretty quickly. We'll spend most of our time talking about our unknown and whether we are given the parts, the percent, or the base. So number 19, if 18 out of 25 students in Mrs. Garcia's first period class received A's, what percent of the students received A's? Use either the percent proportion or the percent equation to find your solution. So the base is 25. That's the total number of students in the class. That means the part is 18. Neither of them is the percent. In fact, we're trying to find the percent. So our part is 18, base is 25, R is the unknown. So I'm actually going to reveal this here. I did percent equation here on the left and percent proportion on the right. So let's go ahead and reveal all of this. You'll notice I got the same solution either way. In fact, if you want to try both to make sure you get the same solution, you are welcome to do that. So P equals R times B would be 18 equals R times 25. Divide both sides by 25 to get that the R percent is 0.72, which is 72%. Percent proportion would be 18 over 25 equals R out of 100. Cross multiply, 25R equals 1800. Divide by 25, you get 72%. No need to move the decimal point when you're using the percent proportion, which is kind of nice. The other thing you might notice here is that 25 times 4 gets you 100. So if you're smart about this, you could just take 18 times 4 to get the percentage. So you can work smarter, not harder, if you can see some of those shortcuts at times. All right, number 20, Trevor received a score of 60% on his social studies test. Oh no, Trevor. If he answered 24 of the questions correctly, how many questions were on the test? Again, you may choose either method. We are definitely given the percent here. It happens to be 60%. And I don't know if I identified PB and R here. I guess we'll find out. I did right here. I was like, I feel like I did someplace. Our R is our percent, and that happens to be 60%. I wrote it as 0.6 for our percent equation, although again, we'll leave it as 60% for the proportion. Now, 24, even though it's next to the word of, 24 is the part of the questions that he answered correctly. So 24 is the part, not the base. In fact, we're trying to find the base, which is the total number of questions on the test. So let me show my work for the percent equation and then the percent proportion. So percent equation is P equals R times B, which would be 24 equals 0.6 times B. Divide both sides by 0.6 to get that the base is 40. The total number of questions on the test would be 40. Percent proportion, 24 over B equals 60 out of 100. Remember, that is P over B equals R over 100. That will get us 60B equals 2,400. Divide both sides by 60, you'll get that the base is 40. So we could say that there are 40 questions on the test. Just a side note that if you do this wrong, so if you accidentally make the base 24, you're gonna get an answer that doesn't make sense. So you end up getting a number that is smaller than 24, and that's not going to be the case. So if you accidentally make 24 the base, you should recognize that, well, if he got 24 correct, how could there be, let's say, 21 questions on the test? It doesn't really make sense. So always think about your answer as well. All right, last two that we have here. So a Reese's peanut butter cup gets 7 of its calories from fat. If this is 8% of the total number of calories, how many calories does a Reese's peanut butter cup have? So 8% is definitely the percent R. As a decimal, that will be 0.08. 7 is the part of the calories that come from fat. It's not the total number of calories in a peanut butter cup. I wish, but that is not the case. So the part is 7, the base is our unknown, the total number of calories, and then R is 8% or 0.08. Now, I did show the percent equation here on the left. P equals R times B would be 7 equals 0.08 times B. Divide both sides by 0.08 to get 87.5 calories. Percent proportion would be 7 over B equals 8 out of 100. That's going to be 8 times B equals 700. Divide both sides by 8. You get 87.5 calories. And we should label our final answer, as you'll see down here that I did. So a Reese's peanut butter cup has 87.5 calories. Again, if you do this wrong, I forget what the answer is off the top of my head, but you end up getting an answer that does not make sense. It's like an absurdly low number of calories. Which again, that'd be great. I'd love that to be the case, but it's just not, unfortunately. All right, our final example that we have here, number 22, a pair of headphones is on sale for $45. This is 75% of the original price. What was the original price of the headphones? This is something we're going to see later on this unit as well when we do some discount, sales tax, types of problems. Our percent is clearly 75%, so R is 75% or 0.75. 45 is the part. It's the part of the price that you pay. We're trying to find the original price, which is the whole, the total, the base in this case. So the base is what we do not know. And this makes sense because when we solve it, our base is going to be higher because the $45 is the sale price. So let's show both of our sets of work. I do want to point out, and I probably should have pointed this out sooner, you do not have to copy down the work for both the percent proportion and the percent equation, but I do want to show both methods here. So P equals R times B for the equation would be 45 equals 0.75 times B. Divide both sides by 0.75 to get $60. That would be the original price, which was higher than the sale price. For percent proportion, 45 over B equals 75 out of 100. Cross multiply, you're going to have 75 times B equals 45 times 100, which is 4,500. Divide both sides by 75, we get that the base or original price is $60. All right, so hopefully you got all of that. This is something that we're going to continue to reinforce in our unit, but I do think it's one that's easy enough for you guys to do on your own, at least to copy the notes, to get those notes so that you don't get too far behind and so we can keep trucking through this unit. But again, it's something we'll continue to reinforce if you're a little unsure about these things, because I realize watching a video, copying some things, you're not going to necessarily feel confident with it until we actually do some practice in class, which I assure you we will do. Thanks for listening.